All right, ladies and gentlemen, this next 10 minutes of physics, we're looking at motion and basically calculating any problem that we're looking for, have a final velocity and a displacement. And we could do a lot with these type of equations. Now, if you look at the equation, you notice we have displacement, acceleration, and the two velocities. And the velocities are squared. So with these type of problems, you're given a displacement and or acceleration and either one of the velocities, and we have to find the other. You will be working with squares and square roots with some of these problems, especially if you have to find either the final velocity or the initial. Sometimes the initial may be zero. So that's, in many cases, that's a good thing. So let's take a look at a problem. The dump truck, and we're going to do some calculations here, some conversions, because if you look at this, and let me change my pen while we're doing this. So we have a velocity of distance over time, 1.8 kilometers per hour. This we need to convert because we need the velocity be in meters per second. And we have a distance and we have a final velocity. So we're looking for the acceleration. So what we have is we have change in x, change in time, VF, VI, and acceleration. And as I said before, we're looking for acceleration. We don't need time in this because this time is nowhere in this equation. So let's go back. We have initial when it begins and it accelerates. So here's our initial, here's our final. So our initial is 1.8 kilometers per hour. And our final is, what would we say, 24 kilometers per hour. We don't need time, but we do need distance. That's 4 times 10 to the second. Meters. So now we do have to convert these two to meters per second. So to set that up, let's do final velocity. That's 24.0 meters per kilometers per hour. Notice how I do this. Kilometers up front, hours on the bottom. So we're going to do this, multiply it. So 1,000 meters is to 1 km, kilometer. So the kilometers cancel, and we end up with meters. Now you can do the calculation and continue, or you just like I'm doing and do it in one big shot. 1 hour, and we'd like to know how many seconds are in those hours. And guys, just know this, 3,600 seconds. So down here, 1 hour, so equal to 3,600 seconds, or 60 squared. That, just go ahead and know this, put it in your head. This is going to be very important. So let's go ahead and do the math. 24 times 1,000, then divide by 3,600, and we got 6.667 meters per second. And we're going to do the same set of calculations for our initial velocity, 1.8 times 1,000, then divide by 3,600. And for VI, it's going to be 0.5 meters per second. All right, so now we got everything converted to where we need to be. And oh, folks, scientific notation, this is 10 squared is 100. So this is basically 400 meters. So let's look at our equation. VI, VF squared is equal to VI squared plus, make sure I get this right, 2a delta x, which is my displacement. So 6.667 Well, before we do that, we need acceleration. Let's go ahead and do the math. Vf squared minus Vi squared equal to 2ax, or delta x. We're looking for acceleration. Divide by 2, and then divide by delta x to move it off to the left-hand side. So Vf squared minus Vi squared over 2x will give me acceleration. So let's go ahead and put the numbers in. 6.667 squared minus 0.5 squared over 400 times 2. So this is going to be 400, and we multiply by 2. And when we do the math, the arithmetic, we should get A, or the acceleration. So make sure you square 6.667 squared minus 0.5 squared. And then we'll divide by 400 times 2, which is 800. And my acceleration get over here, pen, is 0.055 meters per second squared. And that's the acceleration. So remember, folks, this screen is what I'm looking for on the test. I want you to write down the variables, what they mean, tell me how to convert if you have to convert, and then start with the equation that's for the problem, rearrange, and solve. And this is the end of the lecture.